just straight to the parabola part,
Mhm.
to the field goal.
Yeah, it's like an engagement, I think.
Should I say I'm on a football team?
I think it should, yeah.
Oh, wait, don't we have to introduce ourselves first?
Yeah.
Oh,
Yeah.
shoot, I thought we just did. Like, talk through it. You're good.
I'll go last then, since I'm gonna be the one to go first.
Okay, hi guys, I'm Josie. I'm a math education major from Northwest. Go Cats.
Okay, hi, I'm Sloan. I'm special education major. Yay.
Hi, I'm Emily. I am math education from Northwest.
I'm Robert, math education from Northwest.
I'm Trevion, math education from Northwest also, and I play football for Northwest. So let's get straight into it. So did you know you can make money from just kicking a basic field goal? If y'all watch football, what characteristic do you think relates to math when it comes to field goals? And then what?
And then what?
We
We
need
play the
Alon to-
video.
Yeah, we'll
Alon to
play the
kinda-
video.
Should we play the video before we ask that, or should we ask that and then play the video to show?
We can play the video.
I say we ask, do you know you can win $100,000 or whatever by knowing some math? Play the video, get them interested. Like, whoa, what the heck? Then we hop into what characteristics do you notice about this video? Like, what math do you see in this?
Okay.
I took so many education teaching classes last semester that you guys will all take next semester.
Yes. Okay, pretend we just played the video. There you go. How does the shape of the kick relate to what you know about quadratic graphs? Talk about how the path of a field goal kick should look. What do you notice about the shape and features of this kick? What features of the parabola are evident when observing the kick? And how can we represent this parabola in different ways?
And then Robert hops in to our objective.
Oh, what? Oh, yeah, I got it now. I was on the lesson plan. Yeah, so then I'll just let them know that what we're going to be covering is converting between vertex form, intercept form, and standard form of quadratic equations, and identify the key features of a parabola through graphs.
And then we will put up the vocab for them. So during all the stations, they have the different vocab to lean on. And at this point, I would explain the different stations we'll be going to. We have 4 different stations, one with each of our co-teachers. And at one station, there will be a graphing where Josie and Salome will be, and I'll tell them their last name. And they'll go there. And then Trey will have the vertex station. Robert will have the standard form station. I'll have the intercept form, and you each will have 7 minutes per station to work on the worksheet we've provided with our assistants right there. And now we'll each explain our different stations in more detail, starting with Josie.
Okay, so ours is the graphing station, which we are just going to be graphing one graph from each of the forms. And so we'll be explaining how to graph the vertex form, how to graph the standard form, and how to graph the intercept form. And then if there's time, we're going to let them pick their favorite form and then graph that. Again, we're going to be just breaking down and explaining how each form graphs, the vertex of each form, the axis of symmetry, and the x and y intercepts. And then we'll be doing like a little table on the side, so they are graphing all their points x and y by plugging in whatever value for x they want, and then getting the y output to make coordinate points to graph it. Yes.
I'll be doing the vertex station where we have the vertex form of the graph, and we're going to be taking that form and transitioning it to a standard form and also the intercept form. That's all I gotta say, right?
Talk about what the vertex form shows.
All right. The vertex form is defined as y equals a x minus h squared plus k, where h is the x coordinate of the vertex and k is the y coordinate of the vertex. That's really it. Yeah, that's it for the definition.
Perfect.
All right, then I'll be covering standard form, which is your standard quadratic equation, ax squared plus bx plus c, where a, b, and c are integers. Positive or negative integers. The x-intercept is the point on the graph where the line intersects the x-axis. And I'll be explaining how to take it from standard form to intercept and vertex form.
And he'll be using the FOIL method.
Yep.
Mhm.
Yep. And completing the square, all that good stuff.
And then I have intercept form, which is y equals a times x minus p times x minus q. And this shows us the zeros pretty much where the x-intercepts are. So when you see the parabola across 2 points typically, I mean it should, and you'll find the zeros for that. And so we'll be able to convert that to the different forms as well. And then after we do each station, we'll move on to our explanation point.
So we're gonna bring everyone back together after all the stations are over, and I have some questions to ask everyone just to kind of check for general knowledge and what they learned. So what clues did you find most helpful at your stations to understand the quadratic equation? When looking at a graph, how do you decide which forms of the equation to use? What are the advantages of knowing multiple ways to represent a quadratic equation? And then can you think of a real world scenario where it would be crucial to identify the vertex or intercepts of a parabola?
And then I'll kind of bring everyone back in again and just ask if anyone has any misconceptions about any of the forms, how we should get to one of the forms, or how to graph, or really anything about quadratic equations.
And another thing is while they're answering the questions that Salone is asking, if they say something that's not technically right, Robert will also be there to kind of help correct it so that it's not lingering.
Yeah.
And then we'll move on to our elaboration, which starts with Trey.
I'll provide the students with real-world application of quadratic equations. As such, the example used in the beginning of the class as a field goal, and we'll just create more examples for them to use and try to solve and relate it to real world and math, just connect the line together.
Josie, do you want to explain the exit ticket since you did a lot of it?
Yeah. And then we'll be putting the exit ticket on the board for them to complete. This is going to be the equation of it. It's in standard form. It's in standard form, and they're going to convert that to the other forms and then graph it as well and see if the kick made it into the field goal.
And then at the end of our exit ticket, we'll also include a question saying how confident are you switching between the different forms of the quadratic equation, and give them a scale so that they can confidently write how they're feeling, so we can know if we probably need a little more work or if we feel good and we can move on.